Now we're going to be talking about quadratic functions and their transformations. Alright guys, so a quadratic function is defined to be a function that is written as f of x or y, remember f of x and y are the same thing, equals ax squared plus bx plus c. Now ax squared plus bx plus c should look familiar to you because we've been talking about trinomials that have this same form. But we tack on an equal sign and an f of x or a y and it becomes a function. Okay? Now, the shape of a quadratic is a parabola. Okay, so hopefully you remember this from Algebra 1. A parabola kind of looks like a U, but remember, instead of just being straight up and down, it keeps extending in both directions. Okay, so it's going to keep getting larger and larger and wider as the function gets bigger and bigger. Okay, now we can have parabolas that open upward and we can have parabolas that open downward. Alright, so these are the different forms of a quadratic function. Hopefully the terminology parent function you're familiar with now, right? That's where we start before we move anything around on the coordinate plane. We have our standard form, which is just what we were looking at. Ax squared plus bx plus c equals f of x. Remember, f of x is the same as saying y. Now, a cannot be 0, because if a was 0, this quadratic term would go away, and I'd be left with a linear function. And then we have vertex form down here, which is going to be nifty in helping us figure out our vertex and graphing very easily. Alright, so let's go ahead and graph our parent function. So y equals x squared. I'm going to go ahead and pick these points 0, negative 1, negative 2, positive 1, positive 2. So whenever I'm plugging in negative 2, I get y equals, plugging in negative 2. Well, negative 2 squared is negative 2 times negative 2, which is a positive 4. So when I plug in negative 2, I get a positive 4. When I plug in negative 1 squared is going to give me a positive 1. When I plug in 0, 0 squared is 0. When I plug in 1, 1 squared is 1. When I plug in 2, 2 squared is 4. So let's go ahead and plot these points. So negative 2, 4. Let's go ahead and label that guy. All right, negative 1, 1. 0, 0. Positive 1, 1. And 2, 4. Alright, and then we are going to draw our parabola. Now, be careful here, because you might feel tempted to draw a V shape, but it's not a V, right? It's a curve. It must be curved. So there's our parabola. Label our axes. It's y equals x squared. So this is our parent function, okay? So negative 2, 4. Let me go ahead and write that on the side. Negative 2, 4. Negative 1, 1. 0, 0. 1, 1. And 2, 4. Are our parent function points. So those are our go-to points. Those are the guys that we're always going to start at whenever we are graphing. Okay, so please remember that. Now hopefully in this picture you can kind of see some symmetry going on, just like with our absolute value function. Right down the middle here, this line, which is x equals 0, is my axis of symmetry. So hopefully you remember that vocabulary, right? And it's splitting my parabola into two congruent pieces. Okay, here, this is one away here, this is one away here. This line up here is two-way here and two-way here. So it completely makes a perfect reflection of my parabola. So that's why it's the axis of symmetry. And then 0, 0 right here, 0, 0 is my vertex. So these are very similar characteristics as our absolute value function. So here's kind of a summary of what we just said. So our parent function f of x equals x squared, or y equals x squared, same thing. The axis of symmetry always, always, always is going to be x equals 0. The vertex is going to be 0, 0. As you can see in my picture here, here's the AOS, right? It cuts it perfectly in half. From here to each point, we'll have the same distance. Okay. And then our vertex down here is where our graph splits off into its two pieces. So this is important information to know for every parent function. So this is only for the parent function when we haven't shifted anything yet. Now, when we're dealing with parabolas, if a, which again, remember, is just the coefficient of x squared, so it doesn't matter what form you get it in, it's always just the coefficient of x squared. Coefficient means the number in front of a variable. So the coefficient in front of x squared is always a. Whenever a is bigger than 0, which means it's just positive, whenever you see a positive a, that means our parabola is going to open up. All right, so it's going to open up. My two ends are going to be pointing upward. And that means that we are going to have a minimum value. Okay, where the minimum value occurs is down here at our vertex. So that's the smallest value that the function will ever achieve. So we have our vertex x and y, right? Now, the smallest value our x will achieve is whatever the y coordinate of the vertex is. Now, it's not going to be the x because x will achieve bigger values, right? Because x keeps going out and out and out as my parabola gets bigger and bigger. But this is the smallest value our function will ever achieve, and that's our minimum value at the y coordinate of the vertex. Now, if a is less than 0, which means there's a negative sign in front, then we're going to be opening downward. Okay, we're going to be opening downward, and we're going to have a maximum value at our vertex. So when we have our vertex, the y-coordinate now is going to tell me my biggest value that our function will achieve. So you can see at the picture, it doesn't go any bigger than that point, right? There's nothing bigger than that point. So that's our max value, and it's always the y-coordinate of the vertex. So looking at these two examples, 2x squared minus 3x plus 5 equals y. Is it going to be, am I going to have a minimum or maximum value? Well, remember, it's all according to a. Well, in this one, a equals positive 2. Therefore, I'm going to open up, and I'm going to have a minimum value here. Okay, I'm going to have a minimum. Now, down here, where's a? Now, I don't want you to get confused here, because this guy's not written in standard form. You have to rewrite it, put it in standard form. This is negative 7x squared plus 2x plus 4. So a is actually negative 7, right? A is negative 7. Therefore, we are going to open down. And if we're opening downward, then we're going to have a maximum value of our parabola. Now, this is going to be very good for us to remember and know so that we can kind of check our work whenever we are graphing, or we're going to be doing some real-life situations with parabolas, and it's going to be good to know if we have a min or a max value. All right, so for these guys, I want to say, do we have a min or do we have a max? So remember, that all depends on a. So for this guy, a is the coefficient of x squared, so a is 1. So that's going to be, remember, that means we open up, which means we're going to have a min. All right, the second one, this is in vertex form. Our a is this negative 3 out front. That means we open down, and we're going to have a max. All right, for this next one, a is going to be 10, the coefficient of x squared, right? Which means we open up. So we're going to have a min. For this last one, it's not written in standard form, so you have to rewrite it. Rewriting it, you see that a equals negative 6, which means we open down, and we're going to have a max. All right, so domain and range is something that we've talked about before. So remember, domain talks about our possible x values that our function will achieve. Our range talks about the possible y values our function will achieve. Well, when I'm looking at a parabola, a quadratic function, if you look at it, the x values it will achieve, well, it's going to keep going up and up and up and up and out, out, out. Up and up and up and out, 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 out. It's going to keep spreading. It's going to get bigger and bigger. So it's going to achieve all real numbers for its domain. So the domain of a quadratic function is always all real numbers, all right? Now the range is going to vary. The range is going to depend on our vertex. Our vertex is going to be really important, okay? So the vertex is the big key here for figuring out your range. So whenever you're looking at your function, let's look at this function, the vertex is 0, 0. The range, what y values will I achieve? Well, obviously, if I'm this blue function right here, I'm not going to be anything lower than that. I don't have any values down here. So y is going to be greater than or equal to 0. Now, where did that come from? Well, that's the y coordinate of my vertex. If you look at the other one, well, since we're facing downward, so a is less than 0, y is always going to be less than the y coordinate of the vertex, which here is y is less than or equal to 0. So it all depends on the vertex. That will help you figure out where you begin. And then if it's less than when a is less than 0, and it's greater than when a is bigger than 0. All right, so now we're going to take a look at vertex form. So in vertex form, it makes my vertex very easy to see. So if you can see, this is exactly like our absolute value function, where with the absolute value, we had this. Same exact thing now, except for now our absolute value bars are just parentheses because now we have a quadratic function. So our h and k are in the same exact spots, hk, and they tell me my vertex. So my vertex is always hk and the AOS is always x equals h. Alright, so looking at this guy, I want to know what the vertex is. So remember, that's hk, so I have y equals a times x minus h squared plus k. So figuring out where h and k is pretty easy, right? So this is going to be, now I see a positive 1 here, which remember, in order to get a positive 1, I must have plugged in a negative number. So my vertex is going to be negative 1. My k over there is positive 4. Now since my axis of symmetry is whatever the x value of my vertex is, my AOS is going to be x equals negative 1. I am going to, let's see, well, a is a negative 2, which means I'm going to go down. So I'm going to have a maximum. My domain is always all real numbers. And then the range depends on the y coordinate of my vertex, which here my y coordinate is 4. And since I'm opening down, it's going to be y is less than or equal to 4. So those are all the y values I will achieve, and you can see that if you start plugging in numbers, y will always be less than or equal to 4. Alright, so looking at this guy, my vertex is going to be, remember, hk. So since I see a negative, that means I plugged in a positive 1. So my vertex is positive 1. My k over there is negative, so that's negative 4. AOS is always the x coordinate of your vertex, so x equals positive 1. Well, looking at A here, A is a positive 7, which means I'm going to open upward, which means I'm going to have a minimum value. My domain is always all real numbers. And then my range depends on the y coordinate of my vertex. And in this case, my y coordinate is negative 4, but I'm opening upward, so y is greater than or equal to negative 4.
Alright guys, now give this one a try.